In this video we're going to look at stem and leaf plots. We're going to look at how to draw a stem and leaf plot and how to read a stem and leaf plot, in particular how to get certain bits of information from these kinds of plots, including things like a median, upper quartile, lower quartile, etc. So, stem and leaf plot, what is it? It's a bit of an unusual graph. It's probably best described as a cross between a table and a graph. So what we see here, for example, is a list of 10 numbers. So our data set consists of 10 numbers going from 15 to 41. In fact, this list here has been made a little easier for you in that it's arranged in ascending order from smallest to biggest, because that's essentially what a stem and leaf plot does. Underneath the list of numbers that you see at the top there, you've got the actual stem and leaf plot in this blue box. And the stem and leaf plot consists of two parts. It consists of the stem, which is the stuff in green on the left hand side of the red line, and for each item in the stem you've got corresponding leaves on the right of that. All right, so for example, in the stem, in the row for the 1 value in the stem part of this graph, you've got a 5 and a 6. And those two values represent the 15 and the 16 in our data set above. Right, so what you have for the leaf part of the graph is you've got one digit for each of the values you have in your data set, and that goes for any kind of stem and leaf plot. You'll always find just one digit per leaf. The stem part can vary. So in this case here we've got one digit as well, but sometimes there are 2 digits, sometimes you'll get a decimal point in there. Right, so that can vary depending on what numbers you have. But the rule is for the leaves you only have 1 digit. Right, so there are some examples down the bottom here that sort of explain how to read these graphs. So one in the stem, we've got 1, leaf 5, which is that first one that we talked about before. That's a 15. This one here, the 0 in the 3 row, represents the 30 you see in the top. And then that 32 there, that 32 tells you where that is on the stem and leaf. That's the 2 in the 3 row. Alright, so nice and simple. Couple of things you need to be careful about, and we'll do this when we do an example. One is that in the stem part, this bit here, you cannot leave any numbers out. So once you've worked out what's your first number and what's your last number, in this case here the first number is a 1 and the last number is a 4, then you have to write every number in between that in your stem, even if there are no corresponding numbers in our data set. Right, so if you start missing numbers out, then what you end up with is a false representation of the number set in your graph. It's a misleading graph and it defeats the purpose of drawing the graph in the first place. Okay, and the second thing is these numbers here on the right hand side, the numbers that are in the leaf part, they have to be equally spaced. Alright, so the spacing between the 5 and the 6 is the same spacing as between the 1 and the 3 in the next row, and the 3 and the 3 in the next row, and the 3 and the 6 in the next row. So those spacings need to be all the same, so that we get a better picture of what the distribution of these numbers is. Alright, so there's your stem and leaf plot. And as I said before, if we go down, I'll just rub these off, if we go down to this data set underneath, you'll notice that this one here has a list of numbers that have decimals in them. And just as we were talking about this before, you can still write the numbers without the decimal point, but what you'll need to do is you'll need to explain how to read it in a key underneath your stem and leaf plot. Right, so for example, that first 3 that we see in our stem and leaf, right, has a corresponding stem of 2. You don't read that as 23. The key down the bottom here says you read it as 2.3, which is that number there in our data set. Okay, so you don't have to put the decimal point in as long as you explain how to read the graph in a key. All right. Okay, so let's put this to practice. Here's a list of numbers. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. I'm going to first of all draw the stem and leaf for this, and then I'm going to work out some summary statistics and work out the median, upper quartile, lower quartile, etc. Alright, so the first thing we're going to do is we need to work out the smallest value and the largest value in this set, because then we'll need to write out our stem part of the graph. Alright, so the smallest value is this value here. Alright, so that's our minimum. And the largest value is the one right next to it, 31. That's our maximum. Alright, now that we've worked out what our minimum and maximum are, we can then decide on what goes in our stem. So we've got a 3 for 30 going right down the bottom here, and then we've got a 2 for 20, 1 for 10s, and then we'll have to put a 0 in for our 1s because we have a 5 and a 7 that will go in that row. So we'll then put our numbers in. So we're going to try and put these in order from smallest to biggest. Alright, from the left hand side to the right hand side. So the smallest in the first row, in this row here, in the 1s, is going to be 5 and 7. I'll cross those out. Right, so 5 and 7. And in the second row, in the 1s, oh, I don't have any 1s. Alright, I'll still need to keep that 1 there, even though I don't have any teens. Third row, the 20s. Well, I do have a 21. Cross that out. I've got 3 23s. 1, 2, and 3. So write those in. 1, 2, and 3. 3 23s. I've got, next one is a 25. That's a 5. And then I've got a 28. There's an 8. Alright, notice I'm using my grid here to make sure that the numbers are equally spaced. So it gives me an idea of what the distribution is. Alright, and the last row are the 30s. I've got a couple of 30s. Oops, bring this down again. Squeeze that in. A couple of 30s and a 31. So 2 zeros for my 30s and a 1 for the 31. Right, so there's my stem and leaf. And I've got a little key here down the bottom explaining what this is. So 3 /0, that number down the bottom there, right? That means 30. 0 /5 means 5. All right. Now that we've got all that, we can quite easily work out some stuff without having to do too many calculations. So the first thing we can do is we can see straight away what our minimum and maximum values are. We already knew that because we had to know that to draw the graph. So the minimum value is 5, smallest value is 5, the maximum value is 31. And then we can also work out what the median is going to be. Remember, the median is the middle value of the number set. So we have 11 values here. So the median is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The median is going to be the 6th number. So we've got 1, 2, 3, 4, 5, 6. There's our median. What does that 3 represent? That 3 represents 23. Alright, now that we've worked out the median, we can work out what the lower quartile is going to be. The lower quartile is the median, the middle number in the lower block. So the median here, this median divides the number, the data set into 2 halves. Alright, so I've got 5 numbers below that 23 and 5 numbers above it. So the middle value in a set of 5 is the 3rd number. So if I go 1, 2, and 3, this one here is my lower quartile. That represents the number 21. I do the same thing for my upper quartile. So I go 1, 2, 3. This number here, that 0, represents my upper quartile, and that is the number 30. Alright, and then once I've got that, I can work out a couple more things. I can work out the interquartile range, the IQR. If you don't know what this is, go back and look at our notes. The IQR is the upper quartile minus the lower quartile. Right, the upper quartile is 30, the lower quartile is 21. That gives us interquartile range of 9. And then the range, we didn't talk about the range. We don't usually use the range that much. The range is just the difference between the maximum and the minimum. So the maximum minus the minimum. And the maximum minus the minimum is 31 minus 5, which is 26. All right, so quite a few things you can get straight away without having to do too much more work once you've got your stem and leaf. All right, I'll just rub off all these little bits and pieces. All right, down the bottom here you've got an example of more interesting stem and leaf. This is a back-to-back stem and leaf, and they're used to compare two groups. Same sort of thing. So you've got your stem down the middle here. You'll notice that there are 2 digits in one of those rows, and then you've got leaves on either side. And you're always in ascending order from smallest to biggest, inside out. So the smallest numbers are along the inside, and then they get bigger and bigger as they go towards the outside. All right, so we can see from these two classes that class A seems to have better scores than class B. There are more students here than there are in class B. Most of class B scores are in the 60s and 70s. So that class A got better results than class B. All right, that's a brief introduction to stem and leaf plots.